Hello viewers, I am going to discuss about the triangles and its properties. Triangles have three sides. Polygons having minimum sides is triangle. There are three angles. The sum of length of any two sides of a triangle must be greater than the length of the third side. This means that I am showing you if say there are one side 2 centimeter, one is 3 centimeter. Then, if the third side is more than or equal to 5 centimeter, then triangle cannot be formed because of 2 centimeter and 3 centimeter. If this is 2 and this is 3, then sum is equals to 5. And you are seeing here that no triangle is formed. If this third side is greater than 2 plus 3, then what will happen? Like that, this is 2, and suppose this is 3. So, in this case also, no triangle will be formed. So, what is the condition? The sum of the length of any two sides of a triangle must be greater than the length of third side. That is 2 plus 3 should be greater than the third side. Say 4. Then a triangle will be formed. 2, 3, 4. Do you understand? The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. It is the meaning of the statement. And the first point is polygons having minimum sides. We know that fields or figure that have many sides known as polygon. But three-sided polygon are the triangles. Below that, no field or figure will be formed. So, polygon having minimum sides is triangles. The symbol of triangle is like that, is like that. It clearly it may be like that. Okay. So up to this, we get a triangle has three angles and three sides. One, two, three. If I denoted this triangle like as A, B, C, then we can symbolize this triangle as triangle A, B, C. AB, BC, and AC are the sides, whereas angle A, angle B, and angle C are the three angles of this triangle. Now, what are the types of triangles? There are so many types of triangles. Triangles may be classified according to its sides and or according to angles. According to sides, triangles may be classified in three types. We know equilateral, isosceles, and scalar. In short, an equilateral triangle is a triangle which has three equal sides, that is AB equals to BC equals to AC, and three equal angles also, that is angle A equals to angle B equals to angle C. We know that the sum of three angles of a triangle is 180 degree. So in this case, that is for an equilateral triangle, there are all angles are equal to each other. So each angle measures 60 degree. 180 degree divided by 3 equals to 60 degree. It is to be remembered. Some cases, this property will help to solve problems on equilateral triangle. So this is the equilateral triangle where three sides are equal and three angles are equal and each angle is 60 degree, is equal to 60 degree. Isosceles. What is an isosceles triangle? Isosceles triangle has two equal sides and two equal angle. If AB equals to AC, then angle B equals to angle C. For an isosceles triangle, if AB equals to AC, then angle B equals to angle C. So equal sides, base angles are equal. Base angle here, equal sides are AB and AC, and base angle for corresponding these two sides is R, B and C. Therefore, angle B equals to angle C. Now, the third type, scalene. What is scalene? Which has no equal sides. That is, all sides are different in length and all angles are in different in measure. So, scalene is a triangle which has three unequal sides as well as three unequal angles. This is known as scalene. According to angle, triangles can also be divided into three types: acute angle triangle, obtuse angle triangle, right angle triangle. The names implies that acute angle triangle means any one of the angle of a triangle, not any one, all angles of triangle is all angles of triangle are acute angle. Here A, B, C is an acute angle. So angle A, angle B and angle C all are below 90 degree, right? But for an obtuse angle triangle, if any one angle of a triangle is an obtuse angle, then this triangle is known as obtuse angle triangle, right? For acute angle, all three are all three angles are acute angles. But for obtuse angle triangle, if only one angle is an obtuse angle, then this triangle known as obtuse angle triangle. And now we come to right angle triangle. Right angle triangle. What is a right angle triangle? A triangle which has one angle is right angle, then it is known as right angle triangle. Here ABC is a right angle triangle. ABC is a right angle triangle. Here angle B is equal to 90 degree. Here is the figure. Right angle triangle A, B, C, where B is the right angle, that is 90 degree, and opposite of this angle, side opposite to this angle is known as hypotenuse. It is the largest side of this triangle, and another two sides are known as base and altitude. Base and altitude. Here is a relation, famous relation, which is coming from Pythagorean theorem. This is a square plus b square equals to c square, where a and b, the two sides of a right angle triangle, whereas c is the hypotenuse of the right angle triangle. We have to remember the Pythagorean triple: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. So many triples are there which satisfied the relation a square plus b square equals to c square. Like that, if we take 3, 4, 5, then 3 square plus 4 square equals to 5 square. Because of 3 square means 9, 4 square means 16, 9 plus 16 equals to 25, that is 5 square. Similarly, if we check 5 square plus 12 square, then we will get 13 square. Similarly, 8 square plus 15 square equals to 17 square. So on. These are the Pythagorean triple. This is very useful to find out the sides of a right angle triangle, like this way. If one side is 3 centimeter, then other two sides will be 4 and 5, according to the Pythagorean triple: 3, 4, 5. Similarly, if a right angle triangle have has one side is in length of 12 centimeter, then other two sides are 5 and 13 centimeter respectively. In this way, Pythagorean triple will help us to find out the other two sides of a right angle triangle. So, these triples to be remember to quick solve of many problems associated with right angle triangles. It will also help for observation of some properties, which will be helpful to solve many problems on right angle triangles. Now, come to the point: perimeter. What is the perimeter of a triangle? If a triangle ABC has side in length A, B, and C, then the perimeter will be A plus B plus C unit. If it is in centimeter, then the result will be in centimeter. If it is in meter, then the result will be meter. So, perimeter is the length by summing the three sides of a triangle. What is semi-perimeter? Semi-perimeter is nothing but the half of the perimeter. So, if we denoted semi-perimeter by letter S, then S equal to A plus B plus C divided by 2. Now, we are coming to Heron's formula for area. Heron's formula is like that: area A equals to root over of S into S minus A into S minus B into S minus C, where S is the semi-perimeter and ABC are the length of the sides of a triangle. If we know the length of a triangle, the length of sides of a triangle like that, then we easily find out its area using Heron formulas. Heron formula find the area of a triangle A equal to root over of S into S minus A into S minus B into S minus C. Now, for a triangle ABC, if we extend the side BC to D, then we will get an angle ACD. This angle is known as exterior angle of interior angle C of a triangle, and we know that the exterior angle is equal to the opposite sum of these two interior angle, that is BAC and ABC. This relation can be proved very easily like that. This angle plus this angle makes a straight angle, that is angle C plus angle ACD equals to 180 degree. Similarly, we know that sum of any triangle is equals to 180 degree. So, if we compare these two equations, then we will get easily angle ACD equals to angle BAC plus angle ABC, that is angle A plus angle B. So sum of three angles of a triangle is always equal to 180 degree. It is the another property of a triangle already I discussed. Now, what is the altitude of a triangle? Altitude of a triangle is the distance from a vertex, is a perpendicular distance from a vertex to the opposite side. In this triangle, there are three altitudes: AD, BE, and CL. We get AD from vertex A, BE from vertex E, and CF from vertex F. So altitude is the perpendicular distance from a vertex to the opposite sides. Side. What is an orthocenter? Orthocenter is a point where three altitudes of a triangle intersect each other. Here, AD, B, and CF intersect at point O. So, O is the orthocenter of triangle ABC. Median. Line segment from a vertex to the midpoint of the opposite side is known as median. Let the midpoint of BC is BD, then AD is the median. Similarly, E is the midpoint of AC, side AC, then B is the another median of triangle ABC. And also, if F is the midpoint of AB, then CF is the another median of triangle ABC. Right? Already we know that there are three angles. There are three angles of a triangle. If we bisect one angle, then this is known as angle bisector. And there are three angles, so there are three angle bisectors, and triangles have a property that angle bisectors intersect in a common point. Angle bisectors are intersect each other at common point. Let this point be O. This is known as in center because using this center one circle can be drawn inside the triangle which touches all the sides of the triangle. So this point named like that in center. What is circumcenter? If the side of a triangle that is, I am saying that perpendicular bisectors of sides of a triangle intersect at a common point which is known as circumcenter. I am showing it clearly here. Let ABC is a triangle and the midpoint of BC is B. Midpoint of BC is D, then the perpendicular bisector is like that. And similarly, if we draw perpendicular bisector of AC and AB, then this will intersect each other in a common point, say O is the circumcenter of this triangle ABC. This is named like that because this point, this intersecting point O is equidistant from three vertices ABC of this triangle, and using this point as a center, we can draw a circle. Now, I hope you are understand what is circumcenter. Here is a use. Here is a useful property for a triangle, which is if the midpoint of a side D, here in this triangle ABC, the midpoint of side AB is D and the midpoint of AC is E. If we join D and E, then we will find that DE, DE will be parallel to BC, and also D equals to half of BC. It can be proved very easily. It is from a parallelogram, and we know that the opposite sides of parallelogram are equal. So DF equals to BC, and this for these two triangle ADE and CEF, these two angles are equal, and since they are vertically opposite angle and these two angles are also equal, this because they are interior alternate angles, and this sides equals to this sides. So these two triangle are congruent. Therefore, DE equals to EF. Therefore, D is the half of DF. Similarly, G equals to half of BC. Right? In this way, we can prove that relation. We should remember this relation to solve many problems. D equals to half of BC. When AB and C are points on a circle where a line BC is the diameter, then angle BC will be 90 degree. This angle will be 90 degree when BC is the diameter. We know that the chord passes through the center is known as the diameter of a circle. Now, how do we find the area of a triangle? Already one equation, that is Heron's formula, we have discussed to find out the area of a triangle. Here is the alternate formula by which we can find out the area of triangle. Area equals to half into base into height. If we know the height of a triangle and the base, respective base, then the area of triangle equals to half into base into height. Now, what is the area of an equilateral triangle having side A? We know that for an equilateral triangle, all sides are equal, and here given that the length of side is equal to A, and we can prove that the altitude is the bisector of base. How do we prove it? Because of this is 90 degree and this also 90 degree, and this is the common side, and these two sides are equal, so this angle equals to this angle. So triangle ABT and triangle ADC are congruent to each other, therefore BD equals to DC. So D is the midpoint of BC. Using Pythagorean theorem, we can find out the height h equals to root over of a square minus a by 2 whole square equals to root over of a square minus a square by 4 equals to root over of 3a square by 4 equals to root 3a divided by 2. So here base equal to a and the height equals to root 3a by 2. Using this formula, we can find out easily the area of an equilateral triangle equals to half into base into height, that is half into a into root 3a by 2 equals to root 3 square by 4. For an isosceles triangle, it can also be proved that the altitude bisects the base, so the height of the triangle will be equals to root over of a square minus b by 2 whole square, where base is equal to b. Therefore, DC equals to B by 2. So H equal to, by using Pythagorean theorem, H equals to root over of a square minus B by 2 a whole square equals to, like that, root over of 4 square minus B square by 2. So the area equals to half into base into height equals to B root over of 4 square minus B square divided by 4. Two triangles are said to be similar when they are similar when their corresponding angles are equal and their corresponding sides are in proportion. Here is a figure. Triangle ABC is similar to triangle CDE because of the corresponding angles are equal and their corresponding sides are in proportion. That is, CD by CA equals to C by CB equals to D by AB. What are the condition of congruence of two triangles? Two triangles are congruent if their corresponding angles and sides are equal. This means that one triangle can be superimposed on the other. If one triangle can be superimposed onto the other, then these two triangles are known as congruence. A parallelogram can be divided into two congruent triangles. A parallelogram this is the diagonal of a parallelogram. ABD congruent to triangle ABD congruent to triangle BCD, because of, if we fold this part to on this triangle ABD, then it will be superimposed each one another. So triangle ABD and triangle BCD are congruent. If you remember these properties, then this will be very helpful to solve any problem on triangle. Just I am saying rather than explaining. Law of cosines. C square equals to A square plus B square minus 2AB cos C. That is, if a triangle ABC has three sides of length A, B and C, then for this triangle C square, that is the side AB square, will be equals to A square, that is side BC square, plus B square, that is side AC square, minus this two sided minus 2 into these two sides into cos of this angle C, cos of angle C. As you observe that the side A is the opposite side of angle A, the side C is the opposite side of angle C, and side B is the opposite side of angle B. Law of sines is the ratio of side and its sine of angle is constant. Here A by sine A equals to B by sine B equals to C by sine C equals to constant. Okay. If the angle of if the angle BAC of triangle ABC is theta and the two sides AB equals to AC equals to R, then the area of triangle can be deduced like that, half into R squared sine theta. Because it may be proved easily, these two sides are equal, so altitude bisect the base BC. Therefore, triangle ABD is exactly equal to or congruent to ADC. Therefore, this angle equals to this angle, or this angle equals to theta by 2. Therefore, AD equals to R sine theta by 2. Not AD. DC equals to R theta, R sine theta by 2. So, BC equals to 2R sine theta by 2. And AD equals to R cos theta by 2. So, the area of triangle ABC equals to 2 into triangle ADC equals to 2 into half into here base equal to R cos theta by 2 and height equals to 2R R sine theta by 2 equals to R by R into R square by 2 into 2 sine theta by 2 into cos theta by 2. We know that 2 sine theta by 2 into cos theta by 2 equals to sine theta. Therefore, area equals to r square by 2 sine theta. Similarly, we can get this relation area of a triangle equals to half into AB into sine C. Length of median equals to half of length of side it bisects. It is it may be noted that medians divide a triangle into six equal area triangle. Into it is obviously small than the original triangle. 1, 2, 3, 4, 5, 6. 6 numbers of triangles, and these triangles are equal in area. These triangles are equal in area. So, if we summarize this video, then what we will get? We will get the different properties of triangles and types of triangles, and also the perimeter of triangles, the formula, and different formulas to find out the area of triangles, and important some important terms like orthocenter, centroid, incenter, circumcenters. These are very important terms regarding triangle, and the area of isosceles triangle as well as equilateral triangle, and the important property of congruence and similarity of triangles, law of cosines, law of sines. That's all. We have to prepare this lesson very carefully for finding out the measurements of different areas, because of quadrilateral, pentagon, hexagons, and so on can be divided in triangles, and if we find out the area of triangles, then summing this triangle, the area of triangles, we get the area of quadrilaterals, pentagons, hexagon, and other polygons. So you may treat it as triangle is the basic of mensuration. Thank you very much. Before ending this video, I would like to say that thin split and EdTech company is launching a short-term course for preparation of different competitive CBT exams. If any of you interested in this course, you may contact through mail or by phone to know the details of the course. This course will be helpful for aspirants for RRB, PSC, SSC, police examinations, etc. Thank you to all again. Thank you.